Welcome to Electronics Unmessed. This is Klaus. In previous episodes, we saw how to take into account local climate data, temperature profiles, and the thermal conductivity of walls, doors, windows, and false ceilings. We explained this using an example house. In this video, I will explain how other house types can be mapped in our Excel tool. And I have to tell you a few important tricks for that. We want to predict the thermal energy consumption of a house and the possible energy savings through thermal insulation and the behavior of the persons living in the house. We would like to better understand which measures are bringing the most benefit. That could help us when deciding on the one or the other renovation measure. In the last part of our step-by-step guide, we were able to calculate in advance how much energy savings improved windows, doors, and wall insulation can have in principle. That was pretty impressive. And many of you will say, "Hey, awesome! I would like to use this for my own house because it will give me a better way to evaluate my home renovation ideas." However, not everyone lives in a house that looks exactly like our example house with 4 floors. That's why I thought about how to simulate other types of houses. My idea is that you can establish a kind of digital twin of your house for your own virtual experiments. I have now several different house types, and I would like to explain the first 3 of them to you today. Maybe yours is already included. Today we are talking about buildings with pitched roofs. Our example house belongs to this house type. In the last video, which I link you in the top right, I explained all the details on how to map the building with its dimensions and thermal conductivity values, the so-called U values. And I will explain more house types to you in the next video. Yes, it might be worth subscribing to the channel, as there are quite a few videos on these topics. Now we come to the other house types. How can you map a house that has less floors or no basement? At the first glance, the tool seems to be limited to the example house only. A bit of logic will help us here. We just make the first floor the attic. To do this, we take the size of the corresponding areas for the walls, the roof, the windows and the doors of the attic and simply enter them in the next lower floor. Of course, there is no longer an intermediate ceiling to the original attic, which is why we enter the value 0 square meters here. Please do not enter the 0 values yet, because I have to explain something important to you in a moment. Our Excel tool works with thermal energy flows, thermal conductivity values, and thermal resistances. Remember, I explained that principle earlier in detail. If we enter 0 square meters, then logically the thermal conductivity at this point equals 0. This is physically and mathematically correct, but we have a problem with it for the numerical calculation, because we also have to calculate with the thermal resistance. The thermal resistance is the reciprocal of the thermal conductivity. As a result, some values in our thermal resistance matrix would go to infinity. No computer can work with that. What can we do now? The solution is actually very simple. Instead of the value 0, we just take a very small value for the area for example 0.0001. This leads to a very small inaccuracy, but our calculation method then works very well again. We proceed the same way with the specific thermal conductivity values, which we have to enter in the lower matrix. Instead of the value 0, we also enter a very small value here. I took the value 0.0001 here as well. And with that we have already modeled our house, which has a pitched roof and 3 floors instead of 4. That was pretty easy, wasn't it? But you really have to use this null value trick, otherwise it won't work. Incidentally, such numerical problems often cause software developers a lot of headache. But that is not our topic today. By the way, if there is a numeric overflow in the tool, then it will show 0 energy consumption. Next, we want to model a house that doesn't have a basement. Now we apply the same logic again for the walls, doors and the windows. We enter the value 0.0001 for the area values. Now, of course, the interfacing boundary between basement and ground is also omitted, so we enter a small value here. Instead of this, the ground floor gets a boundary surface to the ground, which is 100 square meters. With the U values, we proceed accordingly. The ground floor basement interface no longer exists, so we make the U value very small here. And of course, the U value between the ground floor and the ground must be specified, which was previously 0. Important here to understand the principle. To calculate the energy efficiency parameters, the tool naturally needs the floor space of the rooms. They are entered here, offset diagonally downwards. You need to know that. I forgot to turn off the heating/air conditioning on the top floor that now no longer exists. I will catch up on that right now. As expected, the result does not change, because the top floor no longer exists in the simulation. If this is not the case, then there must be something wrong with your inputs. It is interesting to see that the energy efficiency values become worse with fewer floors. This actually makes sense because the ratio of exterior walls to living space is bigger then. As an effect of this, the energy consumption per square meter increases. Probably each of us expected such an effect. But could you have quantified this effect before? By the way, the insulation from the ground floor to the earth ground is rather bad, which has the biggest impact here in this example. That was the 4th part of our step-by-step user's guide. I showed a few tricks how to model other house types in our tool. I hope that helps you with your own investigations and decisions. If there are still questions about this 4th part, please ask in the comments. I will be happy to answer them. Perhaps you have already started experimenting with the digital twin of your house. Then definitely stay tuned, because I will discuss more possibilities and features in the upcoming episodes. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.